Hello everyone, welcome back. So in this video we are going to understand the LeetCode problem number 396, rotate function. Okay, so what the question is saying that we have given an array num and having length n. So as you can see in the example also, right? So it is saying assume array at k to be an array obtained by rotating nums by k position clockwise. Okay, so you know that how clock moves, right? Like this it moves, correct? And anti-clockwise it's move opposite to this. So it is saying that if we say array k means it's an array obtained by rotating the given array by k position clockwise. So we define a function, rotate function on nums in this way. So this is the rotation we have given. Okay, so we have to return the maximum value of this function at 0 and 1, how much it's rotate, that we have to find. It is saying that the test case is generated so that the answer fits in 32-bit integer. Okay, this is what the problem says. Now if you observe, right, you can see that when we say function at 0 means we are calculating like this, we have 0 into the 4, we are not rotating because we pass 0. Then we have function at 1 which is one position clockwise, right? It means if we'll take one clockwise means we have to start from the 6, right? So 0 into 6, then it comes to the back to the 4, right? And 2, and then 3 and 2, right? Like that we can say. So it generated. Similarly, if we'll go with function add 2, so it will start from the these 2. So if you see this start with the 2, then 6, and then we'll come back to the 4. Like this we will calculate, right? And we'll find the best fit for the answer. The maximum value of this and this is at 26, right? Because f3 gives the max value. So basically we have given an array and we have given a function, right? And at this function, right, let's suppose that we can define a function, right? Let's suppose f at k, we can say, right, it is nothing but 0 into, let's call this a bk for now, right, and plus 1 into bk at 1, and so on. We can say like for the value we have, right, means we can let's add, means 2 into bk at 3 2, then 3 into bk at 3. So these are the numbers we have given till you will reach to the n minus 1 into bk n minus 1. I hope you are getting, right? Plus you can say that. Okay, where what is this bk? Bk is a array rotated k times, okay, clockwise. Okay, you can say clockwise. So if we define a function fk, it will gives you the value, you can say, means you will multiply at this, then this, and so on, you will come till this, right? Means start with the 0, comes to n minus 1, where the bk is the array rotated by k times, right, clockwise, right? So what is our goal? Our goal is to find the maximum between this value. Whatever the value will come is our answer. Means we have to find the maximum value of fk, right, for all the rotations. So you will find the rotations, right, for each k, right? And once you find all the rotations, right, means you have to find the maximum value of the fk, right, for all the rotations, right? So let's suppose that we have given some k value, we have given, right, and we find, let's suppose the k value is nothing but, let's suppose for now K will start from the 0, then 1, then 2, and then 3. That is why this fk is comes to 0 to 3. So fk will always comes from 0 to 3 for now, let's suppose, right? And it gives you the result, because fk is nothing but how many value we have, right? So 0, 1, 2, 3, as a kind of, we can say that, right? Now question comes, how will you solve this problem? It's very important to understand how will you solve this problem. Okay guys, so this is not a thing that you will rotate each array. Let's suppose this is an array where we have seen that 4, 3, 2 and 6 was there, right? And rotation means you are starting from here. Once we have given the rotation, right, 0, you will start from here itself. But when it comes to f at 1, you will go with the rotation, half rotation, means 1 rotation, means you will start from here, not from the here, right? Like this you will go. If the rotation comes for the f2, you will not start from here, right, but you will start from here, correct? So this is called rotation and clockwise, anti-clockwise, guys, right? But the important thing is that you want to rotate the array and then you want to compute f at k, correct? But if you will rotate the array, right, if you will rotate the array each time, so what will give you? It will give you O of n time complexity, and when we'll compute f at k, it will give you O of n. Means total, if you'll talk about, it give you O of n square, and that is not worth here because it will give you a TLE, right? Time limit exceed, it will say, for the larger input. Okay, so instead of recomputing from scratch again, right, means you will rotate, then that you will compute this, right? We should drive a relation between consecutive rotations, right? So you can create a formula, you can say, let's say that let me tell you how. So let's think that if we have a formula fk, which is nothing but f k minus 1 will call, plus we'll say the sum. Okay, there will be some value minus n into, we can say, is nums k minus 1. Can we say that? Like that, if we'll calculate, right, so we can find the better values, right? Why I'm saying that, let's suppose if we will put some value f at k, means the relation will come how? We comes from f at k, then this sum is nothing but, let me tell you, you can calculate this one, right? Then we can find the sum minus n into nums at n minus k for this. Okay, where we'll very first will say that, okay, the approach we should use is, very first we should compute. What we should compute? Sum of array, right? Then we will compute f at 0, right? F at 0 we will calculate here. Okay, and then we will use this recurrence relation. Okay, relation, this recurrence relation we will use in the last. Okay, right? And then we will track the max. This approach will give you O of n as a time complexity. Okay, are you getting or not? Basically what I'm trying to say means we want to get O of n, not the O of n square. Okay, to get this value, to get this time complexity, right, we have to draw a formula. Let's call this is a formula. Okay, where f at k is equal to f k minus 1 plus the sum of the array into n into this is into, okay, into nums at k minus 1, we can say that, right? Not k minus 1, we can say n minus k, sorry, maybe that is why you confuse. N minus k, okay guys. And so if we'll draw this formula, why we'll draw the formula, we'll understand, okay? The very first you should think about why will this work, right? Because this is an intuition, you should understand. So why will this work? So when you rotate, right, every element shift to where? If the array was given 4, 3, 6, 2 and 6, right, like this. So when we rotate, every element shift to where? To the right direction here. Because if one bit is coming, if you see the 6 comes to here, means basically the new array will become is 6, 4, 3, 2, right? Rotation means is this, right? Basically, if you see here, right, this is the given array. When you go for the f at 1, it rotates to here. Now the index 0, 1, 2 and 3, it look like this one, correct? So when you rotate, every element shift to right, and that contributes how much? Plus 1 as a weight. Understand? When we rotate. But when the last element is 6, right? When the last element jumps to the front, right, it loses n minus 1 weight. Got it? So we are adjusting using total sum, right? We will find the total sum, right? And we know that when we find the total sum, we have to subtract what? N into the last element. This is nothing but what? Is a last element, correct? This is n, we will multiply with n into, and this is nothing but what? Sum of the array, correct? So we add total sum and then we will subtract, means this part I'm talking about, okay? Sum, or you can say, yeah, see here, this part, you can understand this part, okay? Means sum is a total array, and that we are doing sum, right? We are doing the plus, as you can see here. Then what we are doing, we are subtracting. What we are subtracting? N into last element. Okay guys, so this is nothing but n minus k is nothing but the last element, right? If you will do n is what? The given number of size, 1, 2, 3, 4, means 4 minus k, you will get the last element, right? Less that, like that we will get it, okay? So basically, the very first we told you that we will compute the sum of the array, then f at 0, and then we'll use this recurrence relation like this: f at k is equal to f at k minus 1 plus sum minus n into the last element n minus k, correct? And this will track the, so this will call third, and this is the fourth, and then we'll track the max, what is the max is coming, okay? This is what we will develop in the code, guys. Let's understand. Okay, so as you can see here, right, let me zoom little bit, okay? Okay, now good, right? So as you can see here, right, what we are doing here, let's think that we have given the array nums, so we'll find n. Then the very first we need to compute is sum and f at 0, so we'll start with the 0, 0, and let's calculate the sum first, right? So sum plus equal to nums at I will do, and each time we will calculate the f at 0, so it will give you I into nums at I, right? So we'll get this value, and we will update f at f0, you can say that. Okay, now comes to the max value, right? And max value is start from the f at 0, and then we have the what is the current max value, we can say that. Okay, so basically we want to track it. Okay, so what we will do, we'll start the k equal to 1 2 will go to the n, right? Because f at 0 1 2 and so on, we have to go till the n minus 1. So what we will use, this recurrence relation will use, we'll say what is the current, we'll find current is current, right? We knew that current is we can calculate it, and then the sum minus n into the last element will find n minus k. So we'll get the current. Now we have to track which one is the maximum, and then we'll get the maximum and we'll find the max here and we'll return the max. That is what we will do, guys. Okay, so let's suppose that if you want to do dry run, let me show you. Okay, so let's think that how we'll solve this problem. Okay, so let's do the dry run first, so we'll understand. Okay guys, so let me go here. The very first thing is, let's suppose we'll use the formula, use the array. Let's suppose the array was 4 3 2 1. No, not 1, it was 6. Okay, like this we had, if you remember. Okay, so this is the array we have given, so we can say like this, it will become array like this. Okay, the very first is we will find the sum. So sum we'll find is 4 3 is 7 2 is 9 and 6. Total sum we got is how much? 15. Okay, then we'll find the f at 0. So let's set how we'll find the f at 0, means this was I'm talking. So we have to calculate this, right? The very first, that if you remember, we got 25. How we multiply over the function, right? So we'll get the 25 from the example, if you remember, right? And then we'll come for the f at 1. So f8 at 1, we know that what we have is 25. We have already calculated, we have already seen, right? From there we just need the sum. What is that sum is we have? So we know that we need the sum minus n, right? So n is nothing but how many? Is 4. So basically we'll write the sum directly here. So this sum is nothing but is 15. We have already calculated here, right? And n, 4 is n, and n is nothing but here is 4. Okay, then we'll multiply is the last element 6, right? So let's calculate it. So 25 plus how much is this here? 24, right? 6 into 4 24, right? Minus 24. So we'll say 15 minus 24. So how much we will get? So not sorry, we did mistake here. Yeah, we'll get 1 only. Okay, so 16, we'll say 16. Okay, then we'll calculate f at 2, because this results into 1 here and here 1, so 16. Yeah, next it will come is we got the 16. So last value we got is 16 plus 15 minus, this time we have the 4 itself, and the last element is now 2, because 2 shift we will do, the last element will become this one, right? So how much we'll get here? Because 16 plus 15 minus 8, so 8 plus 15 is nothing but 23. Then we'll calculate is f at 3, let's say. So 23 plus 15 minus 4 into 3, right? So 23 will say plus 15 means 12, means we will get 3 from here, and 23 26. So you can see we are getting answer 26. That was our answer. If you see, I'll show you what happened. Okay, oh, sorry. So if you go to here, we saw that the output was 26. So this is what I have in this video, guys. In case if you are struggling with anything, you let me know in the comment section. And for the structure of learning, you can join my online classes and you can master DSA to crack the paying interviews. Thank you so much. I'll see you in the next one. And any suggestions are welcome. Thank you so much. And please like, subscribe, and share with your friends. And keep supporting ExpertFunda. Thank you so much.